Hello. Today our topic is subtracting integers, and we're going to learn how to work with them and work with the rules when we don't have a calculator. Later on, we'll explore how to use the calculator. Please take notes and follow along. When we work with subtracting expressions and equations, it's usually advantageous to change subtraction to addition. And we do this because subtracting a positive is the same as adding a negative. So let's explore what this looks like. Using the number line, we have 8 minus 6. So if we started at 8 and then subtracted 6, we would move down the number line 6 units. So we went to the left. We learned recently that when we add two different sign integers, we're really subtracting. So this would also turn into 8 minus 6. And then we would keep the positive sign and still arrive at 2. So generally, we're used to taking a larger number minus a smaller number, and we're comfortable with that. On this last expression, we arrived at 2. But sometimes we have a smaller number and we're subtracting a larger number. So again, on the number line, we could model that. We would start at 3, and then because we're subtracting, we would move down the number line 6 counts again, which would leave negative 3. But there's a way to change that, and we could change, because we're subtracting 6, we could change that to adding negative 6, and we get the same result. We would end up moving down the number line, starting at 3, and moving 6 units, and both times we would end up at negative 3. Our next expression of negative 4 minus 6, again, that's something that's not necessarily familiar. We're starting at a negative number and we're subtracting. Once again, that would move us down the number line. So we would start at negative 4 and we would move down 1, 2, 3, 4, 5, 6 counts. So we landed again at negative 10 and we went to the left. So if we rewrote that, we would write it as negative 4 and adding negative 6. And if you remember the rules, when we added integers, if they're the same sign, we add them and keep the sign. So it turns out that adding a negative is the same thing as subtracting a positive. So we've worked really hard to get our addition rules under our belts. And if you recall, if they have same signs again, we add them and keep the sign. If they're different signs, we subtract and choose the sign of the number with the highest absolute value. And these rules can also help us when we subtract expressions. However, we have to rewrite the expressions first, and there's two strategies. So remember we mentioned that we're used to taking 9 minus 4, but not necessarily 4 minus 9. This might look a little bit awkward. Same with taking a negative and subtracting a positive. And these two last expressions also look a little bit awkward. So if we use this keep, change, change method, that allows us to go back and use our addition rules. And here's what it looks like. We're going to keep the first integer. We're going to change the minus to a plus, and we're going to change the sign behind it. So we would rewrite this as 4 plus negative 9. And now we can recall, when we add different sign numbers, we subtract, and we keep the sign of the number that has the highest absolute value. So this is negative 5. Our next example, we would again use a keep, change, change. So we would rewrite this as negative 6 plus, and we're going to change that positive 2 to a negative 2. Now we have same sign numbers, and if you recall, we add same sign numbers. So we would get 8, and we keep the sign. So this would be negative 8. Once again, this works every time we have a subtraction, so we would do a keep, change, change. We're changing the minus sign to a plus. So this would be written as -7 plus +8. Now we use our addition rules that says that we subtract different signs. So we're going to have 1. And then we keep the sign of the number with the highest absolute value, which is +8. So this is +1. And then our last example, again, we do a keep, change, change. So we would rewrite this as 3 plus, and the second number becomes its opposite, which is +5. We have now two same sign numbers, which we add according to our addition rules, and we're going to get 8. So we keep the positive sign. So I'd like you to try that on the next examples below. We will share out when we're together. After you're done, please restart the video and go on to the next method. There are two different strategies we can use in order to help us. One is keep, change, change, which we just practiced, and the next one is called add a line, change the sign. So when we use this method, we go directly to the minus sign and we change it to addition. So we just add a line to it. It was a minus and we're adding a line to make it a plus. And then we change the sign of the number behind. So it's almost like a little domino effect. We change the sign, we added a line, so we change the sign of the number behind it. Then we're back to our integer rules. So I see different signs, so I'm going to subtract. I'm going to take 8 minus 5, which would be 3, and then I keep the sign of the number with the highest absolute value. So this would be -3. Using this method, I immediately go to the minus sign and I add a line to make it a plus. And then that affects the number behind it, which I see -3, so I'm going to make that a +3. So this would be rewritten as -4 plus +3. Again, these are different signs, so I subtract and I get 1. And now I have to keep the sign of the number with the highest absolute value, which is negative. So this is -1. To use this method, I look for the minus sign and I add a line. Then the number behind it, I change the sign. It was positive, it's now negative. And then our addition rules say when they're same signs, we add them and we keep the sign. So this is 9 and they're both negative, so we keep that negative sign. Our last example, we again look for the minus. Here it is. So we add a line and the number behind it, we change the sign. It's -1, so we're going to make it +1. So I'm just going to rewrite that below to make it a little bit neater. So this is 6 plus 1. Same sign numbers, we add them, and we keep the sign. In this case, they're positive. So once again, would you please practice this method, and then when you're finished, we'll share out in class, and then you can move on to the next part of the video. When you're ready, replay. Okay, please make sure you're on the 3rd page, and we're going to continue our guided notes. Now, it is very important to know that we do not change addition signs. We only change subtraction signs. We only use this when we see a subtraction problem. In fact, our goal is to make it into an addition problem if it's not, using either keep, change, change, or add a line, change the sign. So we have to decide if the following expressions need to be changed. And then we're going to state the reasoning why. So if I look at this expression, I see a plus sign. That's good. We're trying to change everything to addition. And so we do not need to change this to addition. No, because it's an addition problem. So it's already addition. There's no need to change it. We can right now add, because I see two same signs. We add them and then we keep the sign, so that would be positive 10. The next example, ooh, I do see a minus sign. So this, yes, we want to change this to an addition problem. So this first time, I'm going to use keep, change, change. That would be rewritten as 7 plus -8. So again, we want to change something to addition if it's not. So we would employ our addition rule now of subtracting. That would give us 1, and we keep the sign of the number with the highest absolute value, so that's -1, and we changed it because it was subtraction. That's why we changed it. Our next example, I see a minus again. So we're going to change that minus using add a line. Here's the minus. So I'm going to add a line and I'm going to change the sign. So we're rewriting this to -2 plus +5. And yes, we wanted to change that because it was subtraction. And now we've changed it to addition. And we can use our addition rules that state if they're different signs, we subtract. And we use the sign of the number with the highest absolute value. So this would be +3. Our final example, I see a plus sign. So we do not want to change this. It is already addition. So we're going to write already addition. We like addition. We have a set of rules that help us when we don't have calculators. So that rule would say if they're different signs, we subtract them. The integers are different signs, so we're going to subtract, and we're going to keep the sign of the number with the highest absolute value. Our final thought for the day is sometimes we have expressions that are mixtures of adding and subtracting and that have more than two numbers that we're dealing with. So we could use either the keep, change, change method, or we could use add a line, change the sign. And add a line, change the sign may be a little bit more helpful when you have expressions with several integers. So I'll demonstrate why in just a minute, why keep, change, change might be a little bit more challenging. So let's start out with the add a line, change the sign method. When we use this method, remember, we're only concerned about minus signs. So as I look through, I want to keep my plus sign right there. I want to change my minus sign. So I look for the minus sign to change them, and I only change the number behind it. So now everything in this expression is addition, and then I could work with two numbers at a time. I subtract because they're different signs, and the highest absolute value number is positive. Then I'm going to drop down the number I didn't use. And now again, I subtract because they're different signs. So 7 take away 5 would be 2. And I'm going to keep the sign of the number with the highest absolute value. So this answer would be 2. This next example is where I want to show you a keep, change, change. So here's what this would look like if we employed keep, change, change. We would keep the first number. We change minuses, and then we have to change the number behind it. And behind that is another minus, so we would change that, and we would change the number behind it. So we really have a keep, change, 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 change. So that might be a little bit daunting to look at that. So instead of doing that, I would just employ add a line, change the sign. So I look for minuses, I change them to a plus, I change the number behind it. I look for minuses, I add a line to that, and I change the number behind it. So this could now be rewritten as 3 plus negative 5 plus positive 2. Again, if we simplified this, I see different signs. So I subtract 5 minus 3 would be 2, and highest absolute value is negative, so I drop the negative down with it. And we haven't used the other number plus 2. Now I have negative 2 plus 2. I would subtract because they're different signs, and that would become 0. So the answer is 0. This last one, again, if we use keep, change, change, this would look like this. Keep, there's a plus sign, so we keep it. There's because it's followed a plus sign, we keep the 8. We keep this plus sign. We keep this negative 2. And then finally we have a minus sign, so that's what we're going to change, which means we change the number behind it. Again, that looks a little bit daunting. So instead of doing that, I would just scan the problem until I came up to a minus sign, and I'd add a line, and then I'd change the sign of the number behind it. So would you please try this now, and then start the video again to look at the answer. The answer to the last expression should have been 4. So in conclusion, when we have to work without a calculator, you have a choice of using keep, change, change, which you keep the first integer the same, change minus signs to addition, and change the number behind any minus sign to its opposite. Or you can use add a line, change the sign. You'd go directly to any minus signs and change them to addition, which means the number behind them you have to change to the opposite. And that only occurs for any number behind a minus sign. So this is hugely important. We're going to get to this in class when we use a calculator. We enter the expression exactly as is in its original form. So we are not going to change anything when we use a calculator. We only employ these strategies when we don't have the use of a calculator. Thanks for listening to the lesson today, and I look forward to seeing you in person. Thank you so much. Have a great day.